All right, guys, welcome back for our fourth and final installment of the Unit 7 Target 1A B note videos here. This is number four, last but certainly not least, because we're going to put everything together in this video here. All right, so in the last video, in video three, we learned how to algebraically, using our formula, find the vertex and the axis of symmetry. That's important. Again, we talked about it because the entire parabola, both on the graph and both as a table of values, is completely centered around that vertex. And we can see this pattern, this mirrored pattern, a symmetrical pattern, as we go to the right and left of those values there. So identifying the vertex, getting that as our starting point when we're graphing or making a table or really anything to do with quadratics, is going to be pretty pivotal. So that's what we did over here, was we learned how to find that even when, like a problem here, that vertex can't be easily seen using a table and a calculator here. So what we're going to need to do is be able to find the vertex. We're going to have several problems like these. You can see there's four in these notes. When you look at the homework, you can see, guys, most of the homework here are problems like these. And this is just a kind of a process that not only you're going to do in algebra, but you're definitely going to be doing in AAT, where we give you an equation of a function. You're expected to be able to fill in a table of values, use that table to create a graph, and then use that graph to describe characteristics here. So this kind of pattern, this kind of general cycle here is something we're going to see over and over again, both in general form in these notes and in a different form in the next notes, but that's getting ahead of ourselves. So let's take a look at this example here. And the key big difference, if you notice here, in this situation is previously, when we've worked with a table, we have always given you the x values. In the one worksheet that you worked on filling in the tables, you were given the domain values and you had to find the range values. Now, how do we identify these values? Well, one way to do it is we could just, kind of put this in our calculator and then just scan up and down. So if we go to our TI, I go to here. All right, I've got x squared. Let me just click that quick here. Minus 6x plus 8. So minus 6x plus 8. And if we look at the table of that, right, okay, I can kind of scan up and down, and it sure looks like, right here, 3, -1. That's kind of the middle. I see as I go to the left here, as my x values get smaller, 0, 3, 8, 15. As my x values get bigger, 0, 3, 8, 15, right? We can kind of see that that's the middle value. But what if the x value was not clearly seen here? Do you really want to have to scan up and down a long ways? So we're still going to use the calculator to fill in this table mostly. Again, you can always guess and check, but the big key thing is finding the x coordinate of the vertex. And we know how to do that, right? We know how to do that using our formula. So in this case, a is 1, b is -6. Right, so the x coordinate is going to be positive 6 over 2 times 1, which means our x coordinate is going to be 3. So this tells me, guys, that the x coordinate of the vertex, the point that's in the middle, is 3. Well, once I know that, well, I'm just going to walk to the left and the right. So 1 unit to the left would be 2, getting smaller, and 1, and to the right would be 4, and then 5. Now, at this point, you could either plug and chug, right? I could take 1, plug it in, get the range value. 2, plug it in, get the range value. 3, plug it in, get the range value. But this is where being able to use your calculator, guys, makes your life a lot easier. That's one of the reasons we took the time in the first video to work on, putting the equations in the calculator and looking at the table. Because very quickly, once I identify 3 as the x coordinate of my vertex, notice 2, 1, 4, 5, and then 3, 0, -1, 0, 3. So I can very quickly and easily, let's start over. I can very quickly and easily find the domain and range values using my calculator as long as I know the x coordinate of the vertex. That's going to be the key. So I know it's 3, 0, -1, 0, 3. And if this pattern ever, guys, if you think you have the vertex, and it's not the same as the x coordinates get smaller and as x coordinates get bigger, there's something off there. So we've finished our table. We have 5 points here. Let's put them on our coordinate plane here and see if we can't sketch the entire parabola using those 5 points. So we get those 5 points. Clearly, you can see this kind of forms this parabolic curve here. So we'll just go with purple. All right, and outside of these 5 points, it doesn't need to be perfect. All right, you're not going to be reading every point exactly from the graph, but making sure that we have the right general shape and the right location based on those 5 points is what's important. So now we've finished our table of values. We have 5 ordered pairs with the vertex. We have a graph. We have the parabola of the function. Now let's start naming some characteristics. Now, hopefully we practiced this on the previous worksheet. So this is something that we can kind of do pretty well. Domain. Notice that this graph is going to continue to the left and to the right forever, right? And you're probably starting to recognize a pattern in the domain of our quadratics. It probably seems to you that every single problem has the same domain, and that's because every single quadratic does indeed have this same domain. Every parabola will continue unbroken from negative infinity to infinity. And so that's your domain. Now, the range, as we look at the range here, right, we can see we're going to go up forever, but how far down do we go? Well, the lowest this ever hits is -1. So -1 is the smallest value. Infinity is the largest value. We are actually including -1 because it's the y-coordinate of the vertex, and we never include infinity. All right. Now, y-intercept. This is where if you don't make your graph accurately, it's hard to read from the graph. All right. Now, the nice thing, though, is in a y-intercept, we always know the x-coordinate. Remember, we talked about that in the very first set of notes. It's always 0, something. So what we'll do to find our y-intercept, and then I'll show you a shortcut, right, is we're just going to plug in 0 to this equation here. Because if I plug in 0 for x, that will give me the y-coordinate of the y-intercept, right? So 0 times 0 plus 8 equals 8, right? So the y-coordinate of my y-intercept is indeed 8. Notice something here, guys. When you look at the quadratic equation here in general form, notice the constant. Remember, I told you we would use the c value eventually. We didn't use it to find the vertex, but notice the c value is the y-coordinate of the y-intercept. When x is 0, this term is gone, and this term is gone, and all you're left with is the coordinate there. So that's a nice shortcut. You can always do this if you really want, but as long as you're in general form, the c value is going to be the y-intercept of the y-coordinate there. All right, x-intercept. So let's talk about x-intercept here. So x-intercepts, we can see we have 2 of them right there and right there. And so we have 2, 0 and 4, 0. Make that a 0. The zeros, right, we talked about that. The x-intercepts and the zeros have a direct connection in the x-coordinates. Vertex, we already found the vertex there. The vertex was 3, -1. Axis of symmetry. If we know the vertex, we know the axis of symmetry, right? X-coordinate to x-coordinate. And then the last thing is this a min or is this a maximum? Well, obviously, we have a valley situation here. We have a lowest point, and that makes the vertex a minimum. And there we go. We just took a quadratic function, which was given to us as an equation. We created a table of solutions here, a table of ordered pairs. We used those 5 solutions to graph an infinite number of solutions, the entire graph, the entire parabola, and then use that graph with our knowledge of some other details to name the characteristics. All right, and that's what we're going to be doing a lot, not just in this unit in algebra, but going forward big time into AAT. Probably not so much in geometry, but definitely this is going to be a big concept going forward. All right, let's do one more here. Yeah, we'll do the next one. We'll do g of x. This gives us a little different twist because now notice my leading coefficient, my a value, is now negative. All right, so again, how do I fill in this table? Well, the first thing we need to do is we need to know what's the x-coordinate of the vertex so I know where to start the domain values. So Opposite of b is -2 over 2 times -1. -2 over -2 gives me +1. So +1 is what I want here. Now, it's pretty easy. I can go to the left of 1, which is 0 and -1, go to the right, which is 2 and 3. Now, to fill this in, again, I could plug all of these in and guess and check, or we go to the calculator here. So let's go to y equals, and let's now insert a -1. Make sure you use the negative, guys, not the subtraction symbol. And then it was +2. What's the last one there? Sorry, guys. -1. -1. All right. So let's look at the table. And now what I want to do is I want to find 1. I already know 1's the middle. And there we go. Look at that. Nice and neat. -4, -1, 0, -1, -4. So I have my y coordinates now that I got here. And oops, sorry. Let me just look back really quick. -4, -1. So -4, -1, 0, -1, -4. So we have finished our table of values here. So let's come over and let's start graphing here. So 0, -1, 2, -1, 4, 1, -4. We get a nice smooth looking curve from those points, right? And there's our parabola. So we now have the quadratic function as an equation, which was given to us, as a table of values, a table of solutions, and then as a graph of an infinite number of solutions, our parabola here. And now let's do our domain and range. Well, we already talked about, guys, how domain and range is going to just be all of them. Now, the range here, this is the opposite situation. Notice 0 is the highest that ever gets, but it's going to go down forever to -infinity. So the smallest value in the range is -infinity, which we don't include, and the largest is 0, which we do include. Now the y-intercept's nice and neat in this situation. We can see right here, it's right on the graph at 0, -1. Also notice, what's the c value? -1, right? We talked about that's gonna give us our y-intercept there. Now the interesting thing here is we don't have 2 x-intercepts. We have 1 x-intercept, and we'll talk more about this later, but this is a different situation that definitely can happen. We can have 1 x-intercept, which is 0, -1, which means our zeros are -1. Now, also notice that the vertex is an x-intercept, and that's why we only have 1, because there's only 1 vertex, and if that's on the x-axis, there's only going to be 1 x-intercept. If we know the vertex, we know the x-symmetry, and then we can see that this is a mountaintop situation. We have a highest point, so that makes the vertex a maximum. All right, so we just walked through 2 examples in the notes. There's 2 more here for you to try on your own and then check real-time board for the answers there. This takes us to the end of Target 1A and B. So you can now go to the homework here and should be able to work your way through all these problems. The answer keys for all the worksheets are in ClassKick, so you can check those out. Please be asking me questions on ClassKick if things come up. And the last thing that you're going to do when you feel that you've really kind of fully prepared, gone through the videos, gone through the notes, gone through the worksheets, is do the formative assessment and self-grade that by the end of the week, so that we can kind of try as much as possible to keep this idea, this pattern we have of self-assessment, self-reflection, because at some point we will have to be ready for a quiz and a test on this material. We don't know when yet, but we will get there at some point. All right. Well, that was our first kind of set of notes and lessons in our e-learning adventure. Hopefully, this was a positive experience. Please be reaching out. Again, don't panic. Just like My Little Ponies told us, we got this together. All right. Talk to you later, guys, in the next set of notes in Target 1C.